Dear students, welcome back. In the previous lecture, I told you about polynomials. Now, today I'll tell you the relation between the coefficients of a quadratic polynomial and the zeros of a quadratic polynomial. In the previous lecture, I told you that the zero is that number which when we put in place of x in any polynomial, the result is 0. Now, quadratic polynomial. You know, I told you in a polynomial when the highest power of x is 1, then it is a linear polynomial. When the highest power of x is 2, it's a quadratic polynomial. And when the highest power of x is 3, then it is a cubical or cubic polynomial. Now, ax square plus bx plus c. This is a quadratic polynomial. Px is a quadratic polynomial. Now, I told you that in a linear polynomial we have only one zero because the highest power of x is 1. In a quadratic polynomial we will have two zeros because the highest power of x is 2. Similarly, in a cubic polynomial we will have three zeros. So here it is a quadratic polynomial, so we will have only two zeros. Now let the zeros of px be alpha and beta. The zeros are alpha and beta. Clear? Now see, that means if we put x is equal to alpha, then we will get this expression px becomes 0, and when you put x is equal to beta, then also px becomes 0. Now see, if alpha is a 0, then x minus alpha will be a factor of px. Okay, if alpha is a 0, then x minus alpha will be a factor of px. Now, if beta is a 0, then x minus beta will be a factor of px. Clear? Now, we can say that px is equal to k times x minus alpha into x minus beta, because I told you x minus alpha and x minus beta are two factors of px, and k is any constant number. K is a constant number. K is a constant number. So px is equal to k times, if you open the bracket, x square minus alpha x minus beta x plus alpha beta. Now px was ax square plus bx plus c is equal to, if I open this bracket, k times x square minus k times alpha plus beta into x plus k times alpha beta. Okay, if you open the bracket, then you will get this. Now on the left hand side of the equation we have a quadratic polynomial, and on the right hand side of the equation we have a quadratic polynomial. They are equal to each other. So if you compare the coefficients, then you will have k is equal to a, you see, then minus k times alpha plus beta is equal to b, that is the coefficient of x. K is the coefficient of x square here, and a is the coefficient of x square on the left hand side, so k is equal to a. Similarly, b is the coefficient of x here, and minus k times alpha plus beta is the coefficient of the x on right hand side, so they are also equal. And now the constant term, so k times alpha beta will be equal to c, because the constant term on the right hand side is k times alpha beta, and the constant term on the left hand side is c, so k times alpha beta will be equal to c. Now if we simply put a over here, then minus a into alpha plus beta is equal to b, so alpha plus beta will be equal to minus b upon a. Alpha plus beta is equal to minus b upon a. Similarly, if you put k is equal to a here, then a into alpha beta is equal to c, so alpha beta will be equal to c upon a. So we have got two relations between the zeros of a polynomial, quadratic polynomial, and its coefficients. Alpha plus beta is equal to minus b upon a, and alpha into beta is equal to c upon a, where a is the coefficient of the term, a is the coefficient of x square, b is the coefficient of x, and c is the constant term in the quadratic polynomial. So this is the relation between the zeros of a quadratic polynomial and its coefficients. So there is a question based on these relations. The question says, find the zeros of the polynomial. Find the zeros of the polynomial x square plus 7x plus 10 and verify the relationship between zeros and the coefficients. Between the zeros and the coefficients. Between the zeros and the coefficients. So first of all, x square plus 7x plus 10, we are going to factorize this expression by splitting the middle term. You know the method. There are two numbers 5 and 2. When they are multiplied, they give you 10 and their sum is 7. So here you write x square plus 5 plus 2 into x plus 10. Instead of 7, I have written 5 plus 2. Now you open the bracket. X square plus 5x plus 2x plus 10. X square plus 5x plus 2x plus 10. From the first two terms you take x common. From the next two terms you take 2 common. And x plus 5 is common to both. In the other bracket we have x plus 2. Now you can see x square plus 7x plus 10 can be written as x plus 5 and x plus 5 into x plus 2. Now if x plus 5 is equal to 0, then x is equal to minus 5. If x plus 2 is equal to 0, then x is equal to minus 2. So now you can see minus 5 and minus 2 are the roots of or the zeros of this quadratic polynomial. I told you they are also called as roots. So they are the zeros or roots of the quadratic polynomial. That means alpha is equal to minus 5, beta is equal to minus 2. Now you can take alpha as minus 2 and beta as minus 5, that doesn't make any difference. And if you see, if you compare this given expression with ax square plus bx plus c, then a is equal to 1, b is equal to 7 and c is equal to 10. Okay, if you compare the given polynomial with ax square plus bx plus c, you can see that a is equal to 1, b is equal to 7 and c is equal to 10. Now the first relation between the zeros and the coefficient says that alpha plus beta is equal to minus b upon a. Now you see minus 5 plus minus 2 is equal to minus 7 upon 1. Now minus 5 and minus 2 when added gives you minus 7 is equal to minus 7. So it is verified. We have already verified that the first relation is true over here. Now the second one, alpha into beta is equal to c upon a, means minus 5 into minus 2 is equal to 10 upon 1. Now minus into minus becomes plus, 5 into 2 is 10, 10 is equal to 10. So it is also verified. Okay, it is verified. Next question, find the zeros of x square minus 3 and verify the relationship between the zeros and the coefficients. Between the zeros and the coefficients. Now see, x square minus 3 is the quadratic polynomial. Now you see 3 can be written as root 3 whole square. Now we are going to use the identity a square minus b square over here. All of you know that a square minus b square is a plus b into a minus b. So it is x plus root 3 into x minus root 3 using a square minus b square is equal to a plus b into a minus b. Okay, a square minus b square is equal to a plus b into a minus b. Now if x plus root 3 is equal to 0, then x is equal to minus root 3. If x minus root 3 is equal to 0, then x is equal to root 3. So these are the two zeros of the given quadratic polynomial, minus root 3 and root 3. Now let alpha is equal to minus root 3 and beta is equal to root 3. As I told you earlier, you can take alpha as root 3 and beta as minus root 3. It will be the same. And now compare x square minus 3 with ax square with ax square plus bx plus c. Then you will have a is equal to 1, b is equal to 0, c is equal to minus 3, because you can see the term containing x is missing in the given quadratic polynomial. That means b is 0. So a is 1, b is 0 and c is minus root 3. Now the first relation says alpha plus beta is equal to minus b by a, means minus root 3 plus root 3 is equal to minus 0 upon 1. Now minus root 3 plus root 3, it will be 0 only, and 0, and that minus 0 is also 0, so it is verified. The first relation is verified, and then second one, alpha into beta is equal to c by a, means minus root 3 into root 3 is equal to minus 3 upon 1. So root 3 into root 3 gives you 3. You know that minus 3 is equal to minus 3. This is also verified. Okay. So we have found that both the relations between the zeros and the coefficients of this given quadratic polynomial, they are verified. Okay. Next question is find the quadratic polynomial. Find the quadratic polynomial, the sum and product of whose zeros are -3 and 2 respectively. So you have to write a quadratic polynomial in which the sum and product of zeros are given -3 and 2. So let the zeros are alpha and beta, then alpha plus beta is given -3 and alpha into beta is given 2. Now you know the relation that alpha plus beta is equal to minus b by a. So minus b upon a is equal to -3 minus, you can cancel, so b is equal to 3a. Okay, and then you know alpha beta is c upon a, so c upon a is 2, that means c is equal to 2a. Now the quadratic polynomial is ax square plus bx plus c. Okay, now ax square, in place of b you write down 3a, so 3ax. In place of c you write down 2a, and now you take a common, so within brackets you will have x square plus 3x plus 2. Now a is a constant, so although a can have any value, here we will put a is equal to 1. If a is equal to 1, then px will be equal to x square plus 3x plus 2, and that is your answer. If you take a is equal to 2 or 3 or 4 or any number, then also these things will be true. The sum of the zeros will be -3 and the product of zeros will be 2. Clear? Okay. Find the zeros of x square minus 2x minus 8 and verify the relation between zeros and zeros and coefficients. Okay, verify the relation between zeros and coefficients. So they have given px is equal to x square minus 2x minus 8. It is given that px is equal to x square minus 2x minus 8. Now we will factorize this quadratic polynomial by splitting the middle term. You have to think about two numbers whose product is 8 and as there is a negative sign, so whose difference is 2. So it is 4 and 2. So x square minus, in place of 2 you write down 4 minus 2 into x minus 8. Now you open the bracket, x square minus 4x plus 2x minus 8. Now from the first two terms you can take x common. From the next two terms you take 2 common. And now x minus 4 you can take common. So the other bracket it will be x plus 2. So the px can be written in this way. Now if x minus 4 is 0, then x is equal to 4. If x plus 2 is equal to 0, x is equal to minus 2. So 4 and minus 2 are the zeros. We have found the zeros. 4 and minus 2 are the zeros of the given polynomial. Let alpha is equal to 4, beta is equal to minus 2, and a is equal to 1. You can see the coefficient of x square is 1. So a is equal to 1, b is equal to minus 2, c is equal to minus 8. Okay, a is equal to 1, b is equal to minus 2, c is equal to minus 8. Now first one is alpha plus beta is equal to minus b by a, means 4 plus minus 2 is equal to minus 2 upon 1. Now 4 minus 2 is 2 and minus 2 minus plus, so 2, so it is verified. Verified. Now the second part, alpha into beta is equal to c by a. So alpha is 4 into minus 2 is equal to minus 8 upon 1. Now you see 4 into minus 2 is minus 8. So minus 8 is equal to minus 8. So this is also verified. Clear? So in both the parts you can see the left hand side is equal to the right hand side, means alpha plus we have verified that alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. So today we did today I explained the relation between zeros of a quadratic polynomial and with the coefficients of that quadratic polynomial, and we did few sums on that. So I hope these sums are clear to you. So in the next period we'll continue with few more problems, few more examples, but as I told you earlier, along with this video I'll provide the PDF of whatever we are doing here. So you must have made a math notebook, separate math notebook. So you have to copy all these examples that we have done here in that notebook, and those notebooks will be evaluated whenever school reopens. And if you revise using those notebooks during the exams, that would be helpful to you, because the questions that we are going to ask in the exam will be of that type only that we are doing here. Clear? So the main thing, you must have a maths notebook and your work should be complete. Whatever I teach here in the class, you have to see the video, you have to go through the PDFs, you have to do the assignment, you have to keep your notebook complete. So see you in the next period. Thank you.